Hello everybody, this is my submission to the Kotlin Hackathon. It's a past project of mine in which I have improved upon, and it's called Block Qualified. It's an open, decentralized, and fully on-chain education platform where you, or for that matter anyone, can create your own learning experience. So the credential issuer basically can create a test, defining it on our smart contract, and anyone, a solver, can come in, solve that test, and gain a credential that attests to their knowledge of a specific topic. So why is this useful? Well, when you solve a test, the way you do it is that you prove your knowledge of the solution, but you do not reveal it. This is done by a zero knowledge proofs. So thanks to this, privacy is preserved and cheating becomes unfeasible. A malicious solver, as we see here in the figure, cannot come in, copy the solution from someone else, post it as their own. The transaction will revert and they will not be able to gain the credential. So who can actually use this? Well, as a permissionless protocol, anyone can create and solve tests. And by doing so, you can prove that you have the necessary knowledge or credentials on a given topic. And at the same time, you do not reveal anything else about yourself. So by moving exams on chain, you're able to fully decentralize credentials. Now, Block Qualified supports from now 3 kinds of tests: multiple choice, as we are all used to, open answers, where the answer can be any value, or mixed tests, which mix these both types together. Potential use cases of this protocol can be Web3 learning sites, as credentials are NFTs. The market is really used to this idea already. Decentralized contests, you can imagine like a TV show where you answer a series of questions and get a prize, or privacy-preserving job platforms where you prove your knowledge of a certain topic without revealing anything else about yourself. So it's fully open source and it's distributed under an MIT license, so you can choose to deploy your own instance or work on top of another. For now, we do not have any officially deployed smart contracts, but we will in the future. And it actually allows you to interact with any deployed contracts, abstracting away the zero knowledge proof generation, which makes it easy for developers to work on top. So this is an example of that. Here we define a new BQ test on solve mode by giving here the contract address of the test. We're going to generate a proof with a recipient, which will be this address, and given the answers for the open answer questions and the multiple choice ones, and then we just send the solution transaction, which will be this proof, and given it a signer, and we will mint a credential to this address right here. So additional features that we have, since the recipient is embedded inside of the proof, this means that we can use transaction relayers so that the user doesn't even have to care about gas fees. Now, both credentials and tests work as ERC-721s that are non-transferable, and the credential issue can also tweak other parameters like time and credential limits, and also invalidate credentials they own. And so what's next for this project? Well, we are working on an integration with Use Web3, which is a learning platform by Wesley from the Ethereum Foundation. And we'll be looking into gathering feedback after this implementation to improve on the scope of Block Qualified. And we also expect to study a potential integration of Semaphore, which is part of the Ethereum Foundation's privacy and scaling exploration. So links and resources, you can check the full repository on GitHub. There is a documentation as well on how to use all the code, and you can actually check a front end for what was the previous application, which has been improved upon. If you have any questions, you feel free to reach out on Twitter. Thank you so much for watching. Have a great day.